Okay, so we were talking about the arc sine, and we said that this is a little trickier than just reversing input and output. Why? Because when we try to do that, when we make our vertical distance input and angle measure output, well, there's many angle measures going around the circle that achieve the same vertical height. So we needed to limit this range of angle measures so that for every vertical height from -1 to 1, there was exactly one angle measure. So it was like it was really a function. And so we ended up with this range of angles from -π/2 to π/2, so that input y coordinate, see that? Input y coordinate can be as big as what? Nope. Input y coordinate, vertical distance above the horizontal diameter, can be as big as 1 and as small as -1. And so this range of angles from -π/2 to π/2 covers all of those distances from -1 to 1 with just one angle. That's the key, right? It covers all those distances from -1 to 1 with just one angle. Okay, so let's, and so we did this. Arc sine of 2. So where is angle measure of 2? So we're going to take a little different tact on this now. No calculator, okay? No calculator. So 2, we should all know that starting at the 3 o'clock position, counterclockwise, 2 radians or 2 radius lengths is about there. Okay? So if we have the sine of 2 is going to be that. That vertical distance, something like 0.9 something, right? 0.9. So now our sine of 2, that vertical distance is the input into arc sine. Arc sine is going to give us the angle measure between -π/2 and π/2 that has that y vertical distance. Okay, so it's going to be this angle right here, which is different than 2, right? So 2, this is our angle 2. That's 2 radians. So it's going to be something less than 2. So now without our calculator, can we write an expression that would give us that angle? That angle, that's the arc sine of the sine of 2. So any ideas? So this is now what we want. Our output of arc sine is going to be this angle here. How can we express that angle exactly? Any ideas? This is an important thing that we did not do on Friday. So now we're kind of transitioning. So do you see that? So we need to relate it to this angle of 2 radians. How does that angle relate to this angle of 2 radians? So look for symmetry in the situation. Do you see symmetry in this picture that will help us get that smaller angle? Look in quadrant 2. Mm-mm. Look what's happening in quadrant 2. Do you see anything in quadrant 2 that relates to this angle right here? This? Yeah. Yes, right. That's what we should be looking at. This angle right here, that openness, will be the same as this openness that we want. That's the arc sine of the sine of 2. So we can express that right there. What is that angle measure? How can we express that? Should all be able to see that and write an expression that gives that amount of openness right there. In radians. Yep. He wants pi minus 2. That's what that is. Do you see that? half of a circle is pi radians. Take away 2 of them, and you're going to be left with this angle. Do you see it? You have to be able to see that and see this kind of, this is really important now for using sine and cosine, or arc sine and arc cosine. So therefore, the arc sine of the sine of 2 is pi minus 2. So for this vertical height right here, it's the sine of 2, is that vertical distance. Well, it hits a point in the second quadrant and in the first quadrant, so it makes a symmetric V, like that V right there is symmetric. So that the angle swept in the first quadrant is the same as this angle swept over here in the second quadrant, which is a full half minus 2. So then we're saying, okay, by symmetry, that's also equal to this angle in the first quadrant. All right, let's look at arc sine of 6 down here, H. Is there any questions on that? Do you see it? You've got to be able to see the symmetry in these situations in order to answer these questions. So now we want, where is, so 6, arc sine of 6. Is 6 an angle measure or a vertical distance? It's the input into sine. It's an angle, right? So 6 radians. Do you know about where that is? Starting at the 3 o'clock position, you should know about where 6 radians is. Which quadrant? Fourth quadrant. Something like this. No, a little further. Like that. Okay, so there's that's 6 radians, because a radian is openness of 6 radians means it cuts off 6 radius lengths of arc, right? The rays cut off 6 radius lengths of arc. So now that gives us sine of 6 gives us a what? Estimate sine of 6. Just estimate it. Estimate sine of 6. You should be thinking negative 0.4. Negative 0.4 would be an estimate here, the way I've drawn it, right? Because the sine is the vertical distance above the horizontal diameter as a fraction of the radius. So we look at this point at 6 radians, and we get that vertical distance as a fraction of the radius, about 0.4. Now we're going to do the arc sine of that. The arc sine of that means we're going to take that vertical distance, and we want an angle between what and what. We're going to get an angle between what and what that has that vertical distance. Negative pi over 2 and pi over 2. So is it going to be negative or positive? This angle measure, arc sine of 6. It's going to be negative, right? We're in the fourth quadrant. So the angle between negative pi over 2 and pi over 2 is going to be this clockwise swept angle. It's going to be this right here. So can we write that exactly? Can you write that angle exactly? Everyone should be able to do it. That's going to be the answer to our question, the arc sine of the sine of 6. What's that? He wants 2 pi minus 6. That's it. 2 pi minus 6. Good. Because it's going to be... So what do we need? We need to relate that to our angle measure of 6. So full rotation's 2 pi. And then that's going to be what's left when we go, after we go 6 radians, right? After we go around 6 radians, there's going to be that little bit left to get all the way around. So it's going to be a full rotation minus 6. Okay, any questions? This is kind of review and now looking at symmetry and how we find these other angles. Okay, so let's talk about arc cosine. We'll do a little faster this time because you got the gist of what arc sine is like, and actually arc cosine is a little bit easier. So while I'm getting my new my cosine file, I want you to do this. Describe the process of G inverse in terms of what would be the input and what would be the output. Okay, what's the input going to be? For arc cosine. You what's the horizontal distance right of the vertical diameter? Agree? Oops. In what? Fraction of radius. Or in radius. Okay, output. Somebody new. In the reverse process, what will the output be? Which angle? Measure of which angle? Measure of it, which angle? There's a million angles we could define from a circle. So which angle are we talking about? But what is? No. Swept counterclockwise from the 3 o'clock position. Swept counterclockwise from. It's important because I could define an angle swept clockwise from the 12 o'clock, from counterclockwise from the 9 o'clock, clockwise from halfway through the 4th quadrant. So there's a zillion different angles we can measure, and so sine and cosine are always relate to this angle. Okay, so the same thing as before, but now we need so our input is going to be x coordinate. And it's the same issue as before. You pick an x coordinate, say 0.5. So here's x equals 0.5. How many angle measures are there that get us half a radius length to the right of the vertical diameter? How many angle measures are there? How many angle measures are there? An infinite number, right? So here they all are, right? So here's 0.5 to the right of the vertical diameter. All these intersection points are different angles going around the circle in either direction that get us there. So if arc cosine is going to be a function, then we need a range of angles so that all of the horizontal distances from -1 to 1 are hit just once, right? So that is a function. So this is actually a little easier. So what range of angles should we pick so that every horizontal distance from -1 to 1 gets hit just once? Does 0 to pi work? Does 0 to pi give us an angle for every horizontal distance and then just one angle for every horizontal distance? Does it work? Exactly, right. So watch it. Ready? Go. Here we go. Zero to pi. 0 to pi is going to be we're going to cut off cosine to just look at 0 to pi so that every x coordinate corresponds to just one angle measure. All right, again, it could be done this way: arc cosine of x, or cosine of cosine inverse of x, like that. They both mean the same thing. Okay, so here's good. See if you follow what's going on. I want you to give the domain. I want you to write the domain and the range of arc cosine. What are all possible inputs into arc cosine? What are all possible output values of arc cosine? Okay, see if you're tracking. Okay, somebody new. What are all possible input values into arc cosine? It's the least and the greatest. What's our domain? He wants -1 to 1. Yep, that's it. Okay. Range. All possible outputs. 0 to 1. 0 to pi. 0 to pi. Because the range, what the output is the angle measure, right? Angle measures could be from 0 to pi. Okay, practice. Okay, so now no calculators. For all of these, you're either using your knowledge of the unit circle or you're doing what we did at the beginning of class and setting up symmetry to give expressions for the answers. No calculators for these. Okay, so you use your unit circle memory or set up expressions that give exact results. Okay, and I'm going to take attendance. Draw pictures, okay? These are tricky. You got to know what's up. You got to know what's up on these. So cosine of 4 pi over 3 is what? Do you remember from your unit circle? Cosine of 4 pi over 3. He wants -1/2. Agree with that? Yep, that's right. So we're talking about to down here, right? So all the way around like this. That's 4 pi over 3. Cosine's -1/2. So now we're asking what angle, if we want the arc cosine of that of that horizontal position, negative 0.5, we want the angle between 0 and pi that does it. What is it? 2 pi over 3, right? So it's this angle right here. That's between 0 and pi. That corresponds to a horizontal distance of 0.5. Does it make sense? Right, 4 pi over 3 is not in the range of our cosine. It's out of the range. So we get that corresponding horizontal distance, and then we say which angle in the range from 0 to pi has that horizontal distance. Okay, 7 pi over 4. What quadrant are we in? The fourth quadrant, 7 pi over 4. What's the cosine? Right, square root of 2 over 2. So we're talking about, here's 7 pi over 4. And we're going like this. And that gives us is it positive or negative? Positive square root of 2 over 2 is our cosine. So what angle in our range of our cosine has a input of, or a horizontal distance of radical 2 over 2? Pi over 4. Okay, so let's look at, so let's do one more. Negative 7 pi over 6. Negative 7 pi over 6 is in which quadrant? So 6 pi over 6 would be pi, right? 6 pi over 6 would be pi, so 7 pi over 6 is further or not as far? No, it's further. 7 pi over 6, right? 7 is greater than 6. So it's going to be like, trying, oh, right there, okay. Negative 7 pi over 6 is going to be a little bit further than 6 pi over 6. It's going to be like this. That's negative 7 pi over 6. And that, what's the cosine of that? What will the cosine be? Negative radical 3 over 2. Do the cosine. So now we're asking, now we've got that horizontal distance, what angle between 0 and pi gives us that horizontal position? 5 pi over 6. Okay, so what about arc cosine of 5? And we want that as an exact expression, no calculator. So we want to get our symmetry here. So cosine of 5 is in which quadrant? Or 5. Angle 5 is in which quadrant? It's just a little bit past the bottom, right? It's in the fourth quadrant. So an angle of 5 radians is about here. Something like that. So from the 3 o'clock position all the way around there, that's 5 radians. So now we want to get what is the arc cosine of that. What quadrant will we be looking at for arc cosine? Which quadrant will we be looking at for arc cosine? First quadrant, right? We have a positive, so our distance to the right of the vertical diameter is positive, and so that will be the angles between 0 and pi over 2. Now we need symmetry to do this exactly, okay? We need symmetry. So we're looking for what? This angle right here. That's the one. That's going to be the output of our cosine relating to 5 radians swept around. So what will that angle be? Someone said 2 pi minus 5. By symmetry, do you see by symmetry it's going to be the same as this angle right here. If we can get that angle, we'll have this one by the symmetry of it. So is that angle 2 pi minus 5? Yeah, because it would be going all the way around, right? All the way around less this much of it gives you the rest. And by symmetry, that's the same as this. So it'd be 2 pi minus 5. Okay, is this making sense? Okay, let's do our remote control cars. Yeah, we'll pick a different car this time. Okay, so just to remind you, our choices. What did we do last time? Monster truck. All right, so we got the Formula One, Lamborghini, monster truck, and a smart car. Okay, let's make this fast. All in favor of Formula One. All in favor of Lamborghini. All in favor of the smart car. Too easy. Okay. Right here. So we get the smart car. There it is. Okay. So here's the situation. So here's where we put this stuff to work, and we really got to understand what's going on. So our smart car is going to start at the 3 o'clock position, and it's going to cruise around like this. And suppose that it passes the 9 o'clock position, and after it passes the 9 o'clock position, it stops 6 feet to the left of the vertical diameter. Okay, so tell me what quadrant that's talking about. 1, 2, 3, or 4. So after passing the 9 o'clock position, it stops 6 feet to the left of the vertical diameter. Quadrant, I'm hearing 2 and 3. After passing 9 o'clock, it stops 6 feet, something like that. I'm guessing somewhere around there. How far did the car travel? Okay, so how far did the car travel? So what do we have? We have a horizontal distance, or 6 feet to the left. And we want arc length. So what tool do we have? It's going to achieve something like this for us. We have a horizontal distance, and we want arc length. So what tool is going to be the key tool here that's going to work for us here to get what we want? Okay, so arc length is essentially the same as? What's that? Not radius. Arc length is essentially the same as what? If we have arc length, we can get the angle measure, right? Angle measure. So arc length and angle measure are like one and the same for us, right? We've worked hard on that. That arc length and angle measure, simple transition, right? It's very simple. They're virtually the same. So now we've got horizontal position. We want angle measure. What's the tool we're going to use? Sine. Does sine have an input of horizontal position and an output of angle measure? Sine. Inverse sine. Strike two. Input of horizontal position. Output of angle measure. Arc cosine, right? This is exactly what the arc cosine does. Arc cosine. What we just got done doing. Given a horizontal position, input, output, angle measure. Okay, so let's take a look. So this is our 6 feet. One more. There's our 6 feet, okay? So you've got some things to do. This is not a one-step process. This is a multi-step process. But I think if you've tracked with us the last 3 weeks, you've got all the tools to do this. So give it a shot. See how it goes. Take a couple minutes. Work together if you need to. But just remember you got to know your arc cosine, right? What exactly is the input into arc cosine? What exactly is the output? Here's the key. Showing you at the bottom of the screen, right? This is our input and output of our cosine. Okay, arc cosine of what? Arc cosine of what? What's going to go into arc cosine in this situation? Yeah, Brian. He wants negative 6 over 8.5. Negative because? To the left, and y over 8.5. Yeah, good. Excellent. Negative 6 over 8.5. Because we want the fraction of the radius length that we are to the left. So it would be 6 over 8.5 is going to be the input in our cosine, right? Because the input's going to be between -1 and 1. -1 and 1. All right? And what's that going to give us? Is that going to give us the angle measure corresponding to our arc length S? Is that going to give us the angle measure that corresponds to our arc length S? No, it will not. Why not? Which angle measure will it give us? Will it give us that angle measure, arc cosine at -6 over 8.5? You should all be thinking, no, it will not, because it gives us what instead? What's the output of our cosine? What's the range from what to what? 0 to pi. This is outside of that range, right? So it's going to say, if we give it -6 over 8.5, our cosine is going to say, oh, you're giving me this distance right here. You mean that angle, right? You mean this is what, this is our cosine of -6 over 8.5. Because it's going to be the angle from 0 to pi that gives us that fraction to the left of a radius length. Okay, so how are we going to get our angle? So how are we going to get our angle, this red one, right? That's what we need. If we can get that red angle, then we can get the arc length, no problem. So we need to use symmetry. So how are we going to get this red angle if we know this blue one here? Anybody? Two pi minus that? Caroline, what do you think? How are we going to get that red angle if we have the blue one? Pi minus that. Okay. And then? Is that it? Okay, this is one way to do it. This is good. All right. She's right. If you took pi minus that, what would you get? If you took pi minus the angle that we have, what would you get? Where? In what quadrant? No, if you took pi minus this, what angle would you get? You get this angle right here in the second quadrant, right? Right. So this is pi minus our cosine. So we have that angle, then how could we get the red angle? Isn't that the same then as this? That's also this right here. So what's the red angle then? What's the easiest way to get the red angle? Pi plus that, right? So the red one could be like pi plus that. Do you see it? Pi plus this one right here. This is the skill you need to have, seeing symmetry and being able to add and subtract angles to get the one that you want. Okay, is there another way to do it? Another way to get that red angle that we want that corresponds to the distance traveled by the car? Well, you could see that this red angle, do you see that this remaining part to make one full rotation is the same as ours, right? You see that? So this right here is also our cosine of -6 over 8.5 by symmetry. So if we took a full rotation and subtracted that, we would get the right angle. So we could do 2 pi minus. So different way to think about it, but look at what happened. So it's a different way of thinking about it, but how about these two expressions? They're the same, right? It's because we got pi plus pi, that's 2 pi. Pi plus pi is 2 pi minus that angle we found from the arc cosine. So it gives us the same thing, thinking about it either way. Okay, so that is our angle measure in radians. Is that what we want? No, we want the distance traveled by the car. So how do we get the distance traveled by the car? If that's the number of radians, then it's also what about the car's distance? How many radius lengths the car has gone? And so if we want it in feet, we want, it's that many 8.5s, right? So there it is. So it's going to be 2 pi minus this arc cosine, and then times, that's the number of radius lengths that the car went, times 8.5 is then how many feet the car went.
So you also still do like the arc cosine -6/8.5 plus 2 times pi minus negative cosine as well.
This plus 2 of these.
Yes.
Yeah, that works. That's just that's the most complicated expression though. You know, it works absolutely. But do you see that just pi plus that is a little easier?
Yeah.
Yep, you're right though. That arc cosine plus 2 of those, pi minus cosine. Yep, arc cosine. All right, so that's the distance. So let's just get this number and make sure it makes sense. So put this in your calculator. Let's first do the arc cosine of -6/8.5. The arc cosine of -6/8.5. First of all, let's get that. As soon as you get it, tell me. Say it again. $2.35. Does it make sense, and why does it make sense? 2.35. What is that a measure of? Radians into which quadrant? Second quadrant, right? A little bit more than, or like almost 2.5. That's this blue angle right here. That's that blue angle right here. Makes sense, 2.35. Okay, we're going to take 2 pi minus that. Go, 2 pi minus that. What do you get? 3.93? Okay, what angle is that? Does it make sense? Angle to the car, right? It's the angle swept counterclockwise from 3 o'clock to get to our car. Almost 4 radians. Makes sense. It's in the third quadrant. Okay, then times 8.5. Units on that? Feet. Answer. Okay, so the moral of the story is with arc cosine and arc sine, you have to know what's going on. You have to draw pictures. You have to use symmetry. You have to know what the input and the output are of both arc cosine and sine to use those correctly. Okay? So there is web work.